Having just graphed the sum and the difference of two functions, you should find it quite straightforward to graph the product of two functions. All we really need to consider here is that product means that we're multiplying them, and so h of x by definition will be f of x times g of x, or whatever functions we're using. Note that here we're using h, f and g just to keep our notation consistent. So the key idea is that we are multiplying the y values together for any one value of x. Now, a few different things will occur. The one that is the same, I'm jumping down to the bottom, as with sums and differences of functions, when we're graphing products, if either curve is approaching plus or minus infinity, then h of x will also do the same thing. But if our two curves are going in opposite directions, then it might not be clear. So we've seen that already. It's exactly the same thing you should have written down already twice today, and it's going to be consistent. Some other considerations though, if either curve has a 0, then we know that 0 multiplied by anything is 0. So that means that our new curve, our product curve, will also have a 0. That makes sense. If either curve has a vertical asymptote, so will h of x. That makes sense because if we're undefined, then we can't multiply by the other function no matter what it is. If either curve has a y value of 1, what's going to happen? Well, 1 times anything is just whatever the other thing is. So if either curve has a y value of 1, then h of x is going to sit on the other curve. So that's a good point to look out for when you're graphing a product. Look for places where y equals 1. In other words, you'll have a few sketches. Have a look at this horizontal line along here and see where your curve is meeting it. Another point of interest is going to be when y equals minus 1. Now what will happen there is that you'll have, let's say this one was negative 1, then you'd have the negative version of whatever that one was. So it's not, your new curve is not going to sit on this one, but it's going to be, the other curve is going to be equidistant from the x-axis. So let's consider what this means. Let's imagine we've got one curve here that goes through goes through y equals minus 1 here. And our other curve might be a straight line that's like that. Well, if we're multiplying together negative 1, which is this y value, and whatever this is, let's say it was 4, then negative 1 times 4 is negative 4. So this distance of 4 is what we'd see, but down here, and our new curve would go through this point. So that's what I mean by saying if either curve has a y value of negative 1, which this one did, then h of x down here and the other curve up here will sit equidistant from the x-axis. That distance and that distance will be the same. That sort of makes sense. Now, if both curves lie on the same side of the x-axis, h of x will be positive. Now, that makes sense because if you're multiplying two positive numbers together, then you're going to get a positive number. But also, if they're both negative, let's say we've got one that's sitting down here and the other one's down here, and we're multiplying a negative by a negative, that also will give you a positive. So h of x will be positive anytime both of the curves are lying on the same side. So when you're considering the sign of your new function, and we know what we mean by that is it above or below the x-axis, really have a look at where your existing curves are both on the same side. That's where your new curve will be positive. Whereas if one curve is positive and the other one is negative, well, we know that a positive times a negative, no matter which way round they are, will give you a negative number. So that will make h of x negative, and that's going to make it sit below the x-axis because it's going to have negative values of y. So those are our considerations. Now we've already seen with the sums and the differences that if we have the equation of both of the curves, we can literally just work algebraically, multiply them together and graph the new curve if we can. We can also just work on sketches when we don't know the equations. So let's have a look at an example of each of those. Okay, so let's sketch y equals h of x if h of x is defined as f of x times g of x, and we've got a formula here for both f of x and for g of x. Well, all I need to do really to come up with the formula for h of x is multiply these two things together. And I can write it in factorised form like this. Now I don't want to expand this out. I can see that if I did expand it out, then the highest value of x, the highest power of x would be x cubed. So I can tell it's a cubic curve. I can also see it's a positive one because I've only got positive x's. So I know it's going to have that basic cubic curve shape. What I really want to do to be able to graph it simply is to find the zeros. So if I let y equal 0, then either x being 1 or x being negative 2 will cause it to equal 0. So that means I've got zeros at 1 and I've got a double root at negative 2. Now remember what that means. It means that it's an intercept, yes, but the curve is not going to pass all the way through the x-axis here. It's actually just going to just touch it. So if we're starting low, just touching it here, we must go down again and then up again, something like this. And if I wanted to find the y-intercept, I just let x equal 0. So I'm going to have negative 1 multiplied by 2 squared, which is 4. So this must be negative 4. So, okay, my scale's not quite right. Perhaps I should have drawn it coming more down like this. And that would have been a better sketch. Should have found the y-intercept first. Okay, so something like that. Now, could we have done this sketch if we didn't know the formulas? Well, we could, but we'd need a sketch of each of these. So now that we know what h of x should look like, we know it's a cubic curve and it does something like this. Okay, it's a little bit dodgy now, the shape, but you get the idea, something like that. Now let's graph each of these separately and see if we could have come up with this shape just from the sketches. Okay, so just some rough sketches here. Y equals x minus 1 is just a straight line. It's got a gradient of 1 and a y-intercept of negative 1. So it looks like this. That's quick and easy to draw. And y equals g of x is an upright parabola, and I can see that it's like a parabola that goes through the origin, except it's been translated 2 units across to the left. So that's a quick, easy way of knowing that it goes through over here at x equals negative 2. And when I sub in x equals 0, I can see that the y-intercept is 4. So not an amazing sketch, but mathematically a good enough sketch for what we're trying to do. So remember those things that we're looking for here. We're looking for places where y equals 1 on one of the graphs, because that will tell us that our new graph is sitting right on the other curve. So let's do that first. Let's have a look at when x equals 1, we've got, for this curve it's here and say here, and for this one it's over here somewhere. So just thinking about this point, our new graph, y equals h of x, is going to be the multiplication of this y value, 1, by this y value, whatever it is. And so whatever it is going to be exactly where our new curve sits. Similarly, if we've got 1 here, then whatever the other curve is doing, that's exactly where our new curve is going to sit. So that's given me 2 points already. All right, over here, I've got the straight line having a y value of 1. So now, whatever the y value is of my parabola, I haven't actually drawn it up that far, let's make it go a little bit further, that's going to be the y value of my new h of x. So it's going up there. So I've got this point, and this point. Now I need to sort of rough in some more things. So what else can we use? Well, we've got a 0 here. 0 times anything is 0. So that tells me that my h of x is going to go through that point as well, because I've got a y value of 0 and a y value of whatever that is. They multiply to make 0. I've also got a 0 over here on my straight line. So 0 multiplied by whatever y value that is still going to be 0. So that gives me all of these points here, these red ones, to put in. Now, is that enough? Well, it's not super easy to tell what's going on here. I know it's a cubic curve. But if you're not sure what shape to use, you're just going to need to find some more points. What's another clue that we had? Where are the graphs on the same side of the x-axis? That'll tell us the sign of the new curve. I can see that my graphs are on 2 different sides here. That's going to give me a negative sign for this whole section. Until here I've got 0. But then again, they're on different sides, so we're going to be negative again. So that tells me that this is actually a maximum turning point here of my graph y equals h of x, because I know it goes through this point 0, but I also know that on either side, my graphs are on 2 different sides of the x-axis, and a negative times a positive is always going to be a negative. So I can tell it must dip down both ways. I've also got this point here, so I can come down with some confidence to it, and I can come down with some confidence to this point here. All right, what happens now between here and here? Well, it seems like I'm probably going to need to turn around. So let's just multiply some things together. Here I've got -1 times 4. That's going to be -4. So let's put a mark down here at around about -4. I know I need to go down through that. Okay, now I've got a point up here, so clearly I'm going to need to turn around. Now remember that this is a sketch. It's not a perfect graph. It says sketch, so you just want a basic shape. So I've made it to here, and now I've got to consider that I've got to get to here. Well, it seems fairly natural just to go straight up to that point. And now I've gone ahead and I've drawn that same cubic curve that I did before. Last time I did it from the equation of the cubic curve. This time I did it just by reasoning shapes and thinking of values of each of my existing functions, multiplying those y values together to find the new y value of my new function. And don't forget another important clue that you can use when you're working with the sketches and you don't know the actual equations of each function, you can think of what sort of equations they might be. I haven't got the exact equation for this one here in black, but I can see it looks like a parabola. So that tells me that the highest value of x is probably going to be x squared for this one. And this is a straight line. Okay, I haven't ruled it with a ruler, but if I'm looking at this in an exam and wondering what to do, I can tell it's a straight line. So if I'm multiplying together something that's got x squared in it and something that's just got x in it, the highest power of x of my new function I can see is going to be x to the power of 3, and that tells me it's a cubic curve. So straight away I'm ahead because I'm not having to guess what the shape might be. The natural shape of a cubic curve, as it starts to become apparent and I get more dots on the page, is going to be something that I think, oh yeah, that makes sense because I've got a parabola and I'm multiplying by a straight line, and x squared times x is x cubed. So use those little clues. Think of what the function might have as an equation, and that really makes you feel a lot less lost, I think.